Assalamu alaikum students. Students, today we are going to talk about one of the most important topic, that is the Doppler effect. What is the Doppler effect? The Doppler effect is actually the change in the frequency of sound wave due to the relative motion of the source and the receiver. So there are some points that needs to be noted regarding the Doppler effect. The first point that is when the source of the sound wave moves, then the wavelength changes. And whenever the receiver moves, then no change in the wavelength occurs. The third point is that the frequency change, that is actually the afferent frequency that changes in the Doppler effect. So the frequency change is due to the wavelength when the source moves toward the receiver, and the frequency change is due to the relative change in the velocity when the listener moves. The other point that needs to be noted, the frequency change is due to both the wavelength as well as the relative velocity when both the source and the receivers move toward each other, are either they move away from each other. So and the most important point, this is the most important point, and this is one of the crux, this is the crux of all the lectures. And this is the direction, that the direction of the sound wave is taken from source to the receiver. This is one of the most important point. Direction of the sound is taken from source to the receiver. And one of the main formula that needs to be noted regarding this is that whenever we want to find the formula for the afferent frequency or the frequency, the new frequency, it is the f dash. F dash is equal to v plus minus b divided by v plus minus a into f. So what is v? V is actually velocity of sound. So this velocity might have the direction. The direction is actually taken from source to the receiver. So the second point, that is the b. What is b? B here, you can take any other point, but we have chosen the word b. It's already in the KPK textbook. The b is chosen, so it would be easy for the students. So the b is taken as the velocity of the listeners, while a is taken as the velocity of the source. So these 3 points needs to be considered. So frequency is equal to v plus minus b divided by v plus minus a into f. So it is frequency is equal to speed of sound or velocity of sound plus minus velocity of receiver divided by velocity of sound plus minus velocity of source, whole bracket, into original frequency. So the points that would be considered, and now the basic formula, we will actually derive the basic formula from this formula. The first point is, but I have already told you that the thing that needs to be considered as that one point that is missing, that I would like to tell you, that whenever the source moves, this is one of the most important point, and that I would like to write it here. Whenever the two bodies, this is considered as a mnemonics for this, two bodies in same direction, as it is already the case of relative velocity, same direction, they move in the same direction, then add velocity, subtract velocity. You have to subtract velocity whenever they move in the opposite direction. Whenever they move in the opposite direction, then add the velocity. So here, whatever I wanted to tell you, that whenever the velocity of the sound, the direction of the velocity of the sound and the direction of the velocity of the receiver is same, then subtract. And whenever, then add the minus sign between the v and the b. And whenever the velocity, the direction of the velocity of the sound and the direction of the velocity of the source is same, then put minus sign. Now in case of different direction, then put plus sign. So this is one of the most important point that needs to be understood. Opposite direction, put plus minus, and same direction, put minus sign. So this is one of the most important point. So the first point that I would like to consider regarding this is that whenever the source of sound moves toward the stationary observer. So here first look at this formula. Keeping in mind this formula, I would like to tell this is number one formula. Keeping the number one formula in mind, so first I would like to write afferent frequency is equal to, so first this is bracket. As I told you, sound moves toward the stationary observer. Observer is at rest. So initially this is the speed of sound. So and it moves towards the stationary observer, that is to say the listener is at rest. So here I would write plus minus 0. Now keeping in mind v. So now again, speed of sound plus minus, plus or minus, what would I like, as the source moves towards the observer. Now what is actually the direction? Is it the direction, is the direction of the speed of sound and the source same? Are they different? Look, as I already told you, this is the source. This moves in this direction toward the listener, which is at zero velocity. The source, the direction of the speed of sound is always from the source to the receiver. And it is already said this, the source also move toward the listener. So both of them are in the same direction. So here I would like to put as minus sign in A into F. So now here the frequency, afferent frequency, will be speed of sound divided by speed of sound minus A into F. This is the main point. Speed of sound divided by speed of sound minus A into F. So this is one of the most important thing that you needs to consider, as that whenever the direction between the two entities, where it is the source with the speed of sound, direction, as well as the speed of receiver, these two have got the same direction, then you have to put minus sign. And when, or either we can consider any other case, minus sign in case of same direction and plus sign in case of opposite direction. So this is, now as I already told you, that whenever the source of sound moves, then the wavelength change. So here I would like to tell you that the change in the wavelength is due to the change in the frequency is due to the motion of the is due to the change in wavelength. So what will be the new wavelength? The new wavelength is always due to the motion of the source. It's not due to the listeners. So as I have told you, that the original wavelength is lambda is equal to v divided by f. So what would be the new wavelength? You just come to the new wavelength. So new wavelength would be lambda dash. So this is v minus a. Here it is due to the source, so v minus a into f. This is one of the most important formula. So now come to the second point. What is the second important point regarding this? Receiver moves towards the stationary source. So now this is the source, this is the source, and this is the receiver. Source is at rest, receiver moves toward this. Source rest, sound direction, this is the direction of the sound, it moves in this direction. Now here put this formula, basically this formula, frequency. Look, I would put here on this page, frequency dash v plus minus b divided by v plus minus a into f. So here look, so consider this formula. So frequency, new frequency is equal to, so initially Right, look at the above formula, speed of sound. So what would I put? B is the velocity of the listener. So here I would put plus sign or minus as the velocity of the sound waves and the listener in the same or opposite direction. These both are actually in the opposite direction. So for opposite direction, I would actually like to put plus sign. Here when I put plus sign, now I would like to write velocity of the receiver. Now again write velocity of the sound. Now what would I would like to write in this case for the source. If the source is in rest, so plus minus into 0, so this would become here if so this would leads to v plus b into v f. This is one of the main thing. Now I would like to tell you what is the wavelength. Is the wavelength change? No, wavelength not doesn't change. Why? Because source at rest wavelength only changes when the source wavelength only changes when the source moves. So the new wavelength is also lambda dash is equal to v by f, same as the original wavelength. This is one of the most important points. Now the third point that I would like to consider is this: the source moves away from stationary receiver. So the actually the receiver is at rest. This is the receiver, this is the receiver, so this is the source. So this the receiver is at rest, and now the source moves away from the receiver. So what would I would like to write? So now consider what is the direction of sound wave. Direction of sound is always taken from source toward the receiver. So this is the direction of the sound waves. Now consider receiver at rest. Now so here I would like to write frequency, speed of sound. Here I would like to plus or minus. Is actually the source moves in this direction, source moves in this direction, while speed of sound has got the direction in this direction. These both are in the opposite directions. Sorry, first I would come to the listeners. Actually, so listener at rest, so plus minus into 0. Now for the source v, I have written the speed of sound. Now what would I like to write here? So as the source moves in this direction, velocity of sound wave has got the direction in this. So opposite direction we would put plus into a into f. So here I would like to write v divided by v plus a into f. This is one of the most important thing. Now is the wavelength the same or opposite? Wavelength the same or opposite? What would you like to tell me? Wavelength the same or opposite? Wavelength is changed. Wavelength has been changed. So lambda dash is equal to, write this for the source, as the source has moved. Whenever the source moves, the wavelength change. So lambda dash is equal to v plus a into f. This is one of the most important topic. Now the third point that I have considered here: when the receiver moves away from the stationary source, the receiver moves away from the stationary source. So this is the receiver, this is the stationary source. So receiver moves in this directions, and source is stationary. So what would you like to consider? So sound waves moves in this direction. So now I would like to, so frequency dash is equal to, first for the listener, speed of sound. Now here I would like plus or minus. Here actually I would like here to plus or minus. So this is the speed of the receiver. So this is speed of sound. These both are in the same direction. In the same direction, I would like minus sign, v minus b divided by v and plus minus source at rest plus minus 0 into f, derived v minus b into v divided by f. For the wavelength, lambda is equal to v by f as the source at rest. Whenever source at rest, wavelength doesn't change. Now the third point that is actually most important, that is the both move toward each other. The source and the receiver moves toward each other. This is one of the most important point and that needs to be done. So this is the source, this is the receivers. They move toward each other. Always direction of the sound wave is taken from the source toward the receiver. So always direction of sound is taken from source toward the receiver. So frequency a dash is equal to, here I would like to speed up sound. What is its direction relative to the actually relative to the listener. So listener in this direction, speed up sound in this direction, opposite direction for both of them. So here we would like plus into B. Now for the source of sound, actually in first we would like speed of sound. So and the less and the source also moves in this direction. So actually it is the minus same direction, minus A into F. Now wavelength change because source has moved. So lambda dash is equal to V minus A into F. This is actually the wavelength. The wavelength has been changed. So this is basically the same thing that has occurred. Wavelength has actually changed. Now both moves away from each other. This can easily be done, and you could think over it. So the frequency A dash is equal to both away from each other. This is the source, this is the receiver. So both away, this moves in this direction, this moves in this direction. So source speed up sound as I say from source to the receiver first for the listeners. So whenever we write, sorry, camera turn toward other sides. So initially both move away from each other. Whenever both move away from each other, this is the source moves in this direction, the receiver moves in this direction. Speed up sound is direction in it has got in this direction, it has got this direction. So frequency dash, actually first for the listener, the speed up sound, what would you write? Receiver moves in this direction and speed up sound also in this direction. So V plus B. V, what would you write? It moves in this direction, speed in this direction, opposite. Sorry. Speed up sound in this direction, receiver in this direction. V minus B into V plus A into F. So this is the main point. This is the main point that I have considered here. V minus B into V plus A into F. Now has the wavelength changed? Yes, the wavelength changed. Why? Because the source has moved. So the new wavelength is V plus A divided by F. This is the new wavelength has been changed. So many other cases can also be found, but here I have considered some cases, and I hope you might have understand this topic. This was easy. There are some exceptional to the, there are already some exceptional, some cases that cannot be solved through the Doppler effect. So with and this point also needs to be considered. That's are not so difficult. For example, here is the source. Look, here is the source, this is the receiver moves in a circle. It moves in a circle, it's not actually uniform. This is uniform. Receiver moves in a circle, so actually the distance, relative distance doesn't change. So in this case, the Doppler effect, the frequency does not change. So many points has been considered, in which case the wavelength increases. So remember, whenever the source and the receiver, look, wavelength increased in this case. Whenever the source moves away from the receiver, or the wavelength increases, V plus A. And wherever the source moves toward the receiver, the wavelength actually decreases. These are one of the most important points. So I think you might have got it. Okay, thank you very much.